Good day. Our group will be discussing the topic that we chose, which is the tree data structure. A tree is a nonlinear data structure and a hierarchical data structure composed of a collection of nodes, each of which stores a value and a list of references to other nodes. This data structure is a specialized method of organizing and storing data in a computer so that it can be used more efficiently. It is made up of a central node, structural nodes, and subnodes that are linked together by edges. A tree data structure has roots, branches, and leaves that are all connected to one another. Trees are considered nonlinear data structure because their data is not stored sequentially, but rather linearly. Instead, they are organized on multiple levels, forming a hierarchical structure. As a result, the tree is classified as a nonlinear data structure.
Basic terminologies in tree data structures. Parent node. The node which is a predecessor of a node is called the parent node of that node. B is the parent node of D and E. Child node. The node which is the immediate successor of a node is called the child node of that node. Examples: D and E are the child nodes of B. Root node. The topmost node of a tree or that node which does not have any parent node is called the root node. A is the root node of the tree. A non-empty tree must contain exactly one root node and an exactly one path from the root to all other nodes of the tree. Leaf node or external node. The node which do not have any child nodes are called leaf node. K, L, M, N, O, P are the leaf nodes of the tree. Ancestor of a node. Any predecessor nodes of the path of the root to that node are called ancestors of that node. A and B are the ancestors of the node E. Descendants. Any successor node of that path from the leaf node to that node, E and I, are the descendants of that node B. Sibling. Children of the same parent node are called siblings. D and E are called siblings. Level of a node. The count of edges on the path from the root node to that node, the root node has level 0. Eternal node. A node with at least one child is called eternal node. Neighbor of a node. Parent or child nodes of that node are called neighbors of that node. Subtree. Any node of the tree along with its descendants. Nodes. Nodes are fundamental data structures that contain data as well as one or more links to other nodes. Nodes can represent either a tree, structures, or a linked list. It is possible to traverse from one node to another in such structure that use nodes. Root node. A root node is a tree data structures is either the topmost or bottommost node, depending on how the tree is represented visually. If the visual representation is top-down, the root node is at the top, otherwise it is at the bottom. The analogy is that the tree grows from its root to its crown, so the first node is considered the top root.
Recursive node. Each node is the recursion tree represent the cause of the single subproblem in the set of recursive function invocations. We add the cost within each level of the tree to get a set of per level costs, and then we add all the per level costs to get the total cost of recursion at the all levels. Dito sa recursive node, ang bawat node ay sa isang recursion tree ay kumakatawan sa bawat halaga ng isang subproblem sa bawat set ng recursive function invention. At dinaragdag namin ang lahat ng gastos sa bawat antas upang makuha ang kabuuang halaga ng recursion at the all levels. The following are the different types of trees data structure. Binary tree. A binary tree is the nonlinear data structure of the tree type with a maximum of 2 children from each parent. Along with the data element, every node in a binary tree has a left and right reference to root node at the top of trees Herrera. At the binary tree ay isang nonlinear na may data structure na binubuo ito ng uri ng puno at may maximum of 2 children sa bawat magulang sa kaliwat kanan nito. Binary search tree. or BST. A BST, like linked list, is the data structure composed of nodes. The nodes are either null or contain reference to other nodes. Links these other nodes are child nodes known as the left and right nodes. Value are assigned to nodes. Ang binary search tree ay isang advanced na algorithm na ginagamit para sa pagsusuri sa nodes sa kaliwat kanan ng mga sanga nito at namold sa isang structure na puno at ibinabalik ang halaga. AVL3 ang another balanced binary search tree is an AVL3. They were the first dynamic balance trees to be proposed and were the name after their inventors Adelson, Bilski, and Landis. They are not perfectly balanced like the red-black trees, but pairs of subtrees differ highly but no more than one, allowing from and zero log-in search time. Ang LB3 ay isang pang-balancing binary search tree at pinangalanan pagkatapos ng kanilang imbento nila Adelson, Bilski at Landis. At sila ang first dynamically balanced trees to be proposed. B3. A V3 is the self-balancing tree data structure that keeps sorted data allows algorithmic searches, sequential access, insertion, and deletion. The V3 extends the binary search tree by allowing nodes to have more than 2 children. Ang V3 ay isang self-balancing tree ng data structure na nagpapanatili sa pinagsunod-sunod na data at nagbibigay daan sa mga searches, sequential access, insertion, and deletion at algorithmic time. Traversal. It is the process to visit at the nodes of the tree we print their value to. Because all nodes are connected via edge links, we always start from the root head node that we cannot randomly access a node is in a tree. Sa traversal, ang pagtawid sa data structure ay nangangahulugan ng sistemang pagbisita sa bawat element nito. Ang pagtawid ay isang proseso kung saan ina-access ang bawat element ng isang data structure at ang pag-access sa isang element ng data structure ay nangangahulugan pagbisita sa bawat element kahit isang beses. And there are 3 ways which use to transverse a tree. First, in-order traversal. Second, pre-order traversal. Third, post-order traversal. Generally, we transverse a tree to research to locate a given item to key in tree or to print all the values it contains.
So now that we know the basic terminologies and types of tree data structure, let us talk about what traversal is. Traversal is a process to visit all the nodes of a tree and print their value too. Because all nodes are connected by edges or links, we always start from the root node. That is, we cannot randomly access a node in a tree. There are 3 ways which we use to traverse a tree. The first one is in-order, pre-order, post-order traversal. Generally, we transverse a tree to search or locate a given item or key in the tree or to print all the values it contains. So now let's talk about in-order traversal. So what is in-order traversal? So this traversal method visits the left subtree first, then the root, and finally the right subtree. It is important to remember that every node can represent a subtree. If a binary tree is traversed in ascending order, the output will be sorted key values. So as you can see in the diagram, we have a root node A, and it has children which is B and C. root node B has children D and E. Meanwhile, C has F and G. So as in-order traversal said, we will travel through the left subtree first. So in our diagram, the left subtree is letter D. So we'll go through D, and we will check if the child of the root node has an grandchild. So it has. So we'll go through D, and we'll go to the parent, which is B, and now we will go to E, which is the sibling of D. And after that, we'll travel through B, but we already traveled through B. We'll now go to root node, which is letter A, and we'll now go to the right side of the tree, which is the root node C. We'll travel through C, and we'll also go to the left because that's the method of in-order traversal. So we'll go to letter root node F, and root node F has a sibling, root node G. So in-order traversal says that you must visit the left subtree first. So the left subtree in our diagram is letter D, and the next step will be going through the root. But in our diagram, before the root, there's letter B and letter E. So we'll go through B and then E. And the next step will be finally the right subtree. So after we go through the root node, we'll go to the right side of the tree, which is letter C. And after the letter C, we'll go through the left side of the right tree, and that letter is F. And finally, the last node, which is G. So that is how to know the in-order traversal of a tree diagram. So the next one is pre-order traversal. So what is pre-order traversal? Before visiting any nodes within the left or right subtrees, go to the current node. Visit the current node after visiting all the nodes in the left subtree, but before visiting any nodes in the right subtree. The last traversal method is post-order. The left-right route policy is followed by the post-order traversal technique. Left-right route denotes that the left subtree of the root node is traversed first, followed by the right subtree, and finally, the root node. In this case, the name post-order implies that the tree's root node will traverse at the end. As you can see in this diagram, we have root node A. It has children B, C. BC has children D, E, F, and G. So in this method, we're gonna use the left-right route policy. So we're going through the left side of the tree. And the left side of the tree has a node subtree, which is node D. So we're gonna follow left-right route policy. We'll go to left, which is node D, and right, which is node E. But if there's nothing else under the node D or E, we're gonna ascend through its parent, which is node B. So after that, we're gonna follow the left-right route policy. So the left of this tree is B, and the right tree of this tree is C. So again, we're gonna follow the left-right route policy in this node. In this node C has children's, which is F and G. So again, left-right route policy. We have F in the left and G on the right. So after we go through the left-right route policy, if there's nothing else under that node, we're gonna ascend through its parent. And after we ascend through that parent, if there's nothing else on the left and right of that node, we're gonna send to its root. So that is how you get the post-traversal method. So that is how you get the post-order traversal of this diagram. So the post-order traversal of this diagram is D, E, B, F, G, C, and A.